Good afternoon. It's a pleasure to welcome you to our broadcast titled Cross-Geo Deployment with Redis Enterprise. Our presenter today is Shihan Bikolu, Vice President of Product Management at Redis Labs. Deploying Redis Enterprise in a geographically distributed manner requires some thought and planning. During this webinar, Shihan will discuss some of the issues you will encounter when you distribute your Redis system across multiple geographies and how to solve them. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. Shihan will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you can use to post questions. Those questions will be answered in the order that they are received. Thank you again for joining us today, and at this time I'll turn the broadcast over to Shihan. Shihan, take it away.
Thanks, Sharon. Hi, everybody. I'll quickly go over what we're going to cover today. I'm going to give you a quick overview of the Redis Enterprise platform and the technology that we've developed, talk a little bit about our company. And I want to spend a little bit of time giving you an overview of the replication architecture within Redis Enterprise. We've got a number of different replication capabilities that we've built and tuned for specific types of networks, and we'll detail that. And finally, I want to show you a couple of the topologies that are common with many of the customers that we have today, and some of the ones that we're expecting to see in future with some of the newer technology that we'll talk about. And after that, we'll have some time for question and answers as well at the end, so we'll have a chance to chat in free form. All right, let's start with the Redis enterprise technology. First, Redis Labs, we're the commercial company behind open source Redis. We're the team that is contributing the top set of changes to this product. We also have a specialized platform, Redis Enterprise, that we develop that adds enterprise level capabilities on top of Redis. We provide our product, the Redis Enterprise platform, the underpinning for all of these technologies in a variety of different forms. You can get Redis Enterprise in a form of services under Redis Cloud or Redis Cloud private offerings. These are managed solutions in public clouds where we provide full DevOps capabilities for you. Or you can get the same technology as packaged software and run it yourself. We call this technology Redis Enterprise Pack. We can also help you manage that technology through the Redis Enterprise Pack managed offering. Now, the technology has been around for a while. At this point, it is mature and stable, and there's some impressive numbers that we manage both in the cloud and on-premise solutions. Today, we run over 250,000 databases with our solution. There's 600 new databases that are created every day on our solution, and we've survived through thousands of node failures within our environments and survived these outages without data loss. The technology has grown over the years, and on the cloud side, we have close to 7,000 enterprise paying customers and over 200 customers on the Redis Pack on the on-premise deployments that we have. We also have a free tier where there's a large number of customers who take advantage of our offering in the cloud and on-premise, and there are 60,000 total accounts that have active databases with our technology today. That's beyond the open source deployments, obviously, of Redis, which is much, much larger. This is a quick overview of the set of verticals that we operate in. We're pretty much in every vertical industry and work with many of the marquee names that you might recognize with this technology. So we've helped create solutions with many of these customers. All right, let me dig right into the architecture a little bit of Redis Enterprise, and especially the replication topologies that we support. I'll start with a quick overview of the node. So this is a high-level overview of what each node contains in the Redis Enterprise Architecture. On the bottom, the red section, you see the Redis open source shards. There are many of these in every node, and it depends on the node size as to how many of these you get to place. You can get to control these things, and the number of Redis open source shards that you may have can vary over time without any downtime. So you can reshard to more number of shards within the node. There's also a cluster management tier that provides a number of different capabilities on top of the open source Redis shard. And this is where most of our IP resides. So one of the capabilities that we provide is a proxy that hides the complexity of scale-out architecture and multi-key operations. It's a zero latency proxy technology. There's cluster management. This is the governor of the cluster that ensures we can detect and cure failures and bring the cluster back to healthy. And there's a secure UI and a REST API that allows you to interact with the platform. At a zoomed out view, a little bit, this is what the cluster looks like. Each node, if you haven't noticed, is identical. In our case, it's a shared nothing cluster architecture. And it makes scalability easier. So for you to gain any additional scalability, all you need to do is add more nodes and spread the shards. It is fully compatible with open source Redis. So all you need to do is simply change your connection string and point to our platform from open source applications that are running on Redis, and voila, you have a scalable, highly available Redis platform that you can work with. When it comes to replication technology, this is the capability that ultimately allows us to build a distributed database platform that you can rely on. We look at a few important things. Obviously, Redis is a piece of technology that can achieve large number of operations per second. So replication throughput is one of the things that is important to us, and we've designed our replication technology differently to make sure that we can gain those throughputs. And the latency of operations within Redis are critically important. So the replication also takes into account the replication lag as we develop these. Depending on the type of network we are operating in, we have various different replication technologies to customize our performance. So we provide local replication capability that's built for LAN, local area networks. Local area networks are typically high bandwidth and low latency, and we can take advantage and exploit all of these high quality properties of the local area network to replicate quickly. When it comes to wide area networks, we typically expect lower bandwidth and higher latencies, and there's a noisier traffic or quality to the network that we run on, and we tune our cross Geo Replication technology to be able to run within the WAN when attributes. Let's take a look at local replication just quickly. This is a quick overview of a 3-node cluster. The master shards are marked with the letter M, and they're distributed across a couple of nodes. And the local replication is responsible for maintaining the slaves that are marked with the letter S. This is what we do for the local network. This is optimized to be able to carry replication carry your updates to the master shard quickly to slaves and give you data durability across multiple nodes. When it comes to Geo Replication, when we have to operate across WAN, there's a couple of things that we provide in terms of replication topologies. Now, the picture that you're looking on the right of the slide represents site A and site B and C. So we provide a unidirectional replication capability where the data in site A can be replicated to site B and site C. We call this the replica capability, and essentially a source database is carried over to a destination database across the WAN. Now, this replication, we'll look at the architecture, is built to be able to cross higher latency networks. So, if you're going from the European continent to the American continent, the latencies of 100 to 300 milliseconds are the things that we can tolerate with this replication, and we tune its parameters to be able to absorb the characteristics of those networks and the chattiness and the noisiness of these networks. Let me quickly dig into the architecture of the replica of replication here. I see a question come in, so let me take that. So the question is, what is the replication lag with each one of these replication technologies? Well, it actually depends on your local infrastructure in many cases, but the replication lag with local replication is as fast as you can get the ping latency to us, almost. We're fairly aggressive in queuing and replicating the information over to other slaves to minimize any discrepancy between the two. So your writes, as they hit the master shard, are immediately replicated to slave shards. When it comes to replica of, again, majority of where the time is spent is the WAN latency. So the ping latency between the two sites, the source and the destination databases, those are typically the main components of our latency. Otherwise, the replications technology that we built is memory-based and is aggressive to try to carry all the information as quickly as possible to the other side. So that's what we have. All right, going back to this picture, what you see on the left side is the source database, and the right side is the destination database. We actually manage a compressed stream that is sent back and sent from the source database to the destination database. And the process that ensures the coordination between the source and the destination databases is called the syncer. It's responsible for the efficient initial sync, the ordered replication that we have to maintain so that we can apply the operations in a given order, and the pausing and resuming replication. Those are the responsibilities of the syncer in the middle. Now, when it comes to geo replication, there's another type of replication that we're working on that is coming soon with the next major release of our technology of Redis Enterprise, and it's a multi-master replication. In this case, site A, site B, and site C all receive writes and can replicate the changes to each other, and they coordinate writing to the same set of data concurrently. We use a capability that allows us to do concurrent active-active writes across these sites and still be smart about resolving the write conflicts. They're managed by a technology called CRDT. It stands for conflict-free replicated data types. And I just want to take a moment just to explain what CRDTs are, since they're a fairly new concept. So CRDTs are built for low latency replication with smart conflict resolution, and they essentially provide a consensus-free reconciliation mechanism for us to be able to write at the rates that Redis can do. That could be millions of operations a second, and still be able to maintain a complex data structure like list or a sort in reasonable shape. Whenever there are conflicting writes, instead of falling back to an unintelligent last write wins type conflict resolution mechanism, we can be much smarter through the use of the CRDT technology. I'll dig a little deeper into what CRDTs provide just to give you the full picture. There's a lot of academic material that you can go read about the mathematical model behind it. But CRDTs essentially are essential for us to provide the strong eventual consistency. What we do is we essentially maintain a vector clock for each of the objects and sub-objects. And for those of you who don't know much about Redis, I'll just mention this. It's that there are key value type of excess that you can have, but Redis is also very much popular for the more sophisticated data types. It provides the list, sorted sets, hyperlog, log, and many of the capabilities that come through these sophisticated data types can actually allow you to have sophisticated verbiage on top of them. And a hash table, for example, can add or remove different cells within that hash, or a list can add new list items, or a sorted set can acquire a new item and sort it correctly into the list of scores that it maintains. So with those more sophisticated data types, it's important to be able to look at the type of conflict, not just blindly look at who the last writer was, and be more intelligent about how we can maintain those multiple concurrent writes. So the last portion of the slide lists out a couple of the techniques we use, like the cumulative, associative, or idempotent properties of the writes that you make to these data types. And with use of these, we can be smarter about how we resolve these conflicts. Imagine maintaining counters, a geo-distributed set of counters, for example. Obviously, if you've got 100 likes in the US and 200 likes for that same article in Europe, the correct way to resolve that right conflict is to come up with the number 300 for the number of total likes. The problem with operations or conflict resolution techniques like last right wins is you would either have 200 or 300 win in those cases when you actually replicate these changes. So the cumulative nature of what our counter data type provides allows us to end up with the result 300. That's true for some of the other data types that are collecting events. So if you have a list or a set, what we can actually do if there are multiple events that you're tracking in different geographies and different sites, we can actually take them and essentially collect all of these events together, as long as they're not conflicting with each other, and accumulate the set of events for you to, let's say, detect fraud across geographies. There are many more examples of this in academia, and there's a good set of write-ups, so I'll leave it here. But CRTCs is a sophisticated way, essentially, to resolve the conflicts that you see. And in our case, there are certain cases where we can't ultimately have a more intelligent way to resolve the conflict, and we will fall back to last right wins. But ultimately, for many of the data types, we actually find ways to make them resolve their conflicts with the sophisticated techniques that we described above. All right, that's the quick description of some of the architecture within our product for replication and what technologies we provide. I want to go next into a couple of the common topologies that we see across our customer base. I'm going to describe 3 of them to you that are fairly common. So I'll start with topology 1. This is mainly a content distribution technique where a read-heavy workload across geographies wants to be able to read locally with low latency. So the database that you see, the Redis E logo that you see over the Americas, that replicates the information to a variety of continents. There's cascading replications to other geographies that you can establish as this CDN-like capability, so you can distribute all of this data. I see another question come in. Do I need to schedule downtime to enable replication? Now, the answer is no. These techniques, the replica of capability that is behind the topology, is something that you can enable online without taking any downtime. So yeah, these capabilities are quite flexible. Now, the content distribution capability, that's fairly obvious, but obviously you can get your content closer to users, so a user in Europe doesn't have to travel across the ocean to read the data, but can depend on the local copy of that data to read. It's much more responsive applications and snappy UIs that you can build with this. All the writes go to the main database in this case, so avoiding write conflicts is another great advantage of this. Obviously, the writes have to travel back through that long latency, so sometimes that may not be great if you've got a lot of writes in your workload. The technique of obviously distributing copies of your data to other geographies increase read availability. That's fairly obvious. One important thing to note here is probably that the fact that you can actually see a variety of sizes of Redis logo on each one of these geographies, and that actually represents the fact that you can independently size each one of these regions. That means you can have an 8-node cluster in the US and a 3-node cluster in Europe. If the workload doesn't require any more than that, you don't have to. So we're size independent, and there's no requirement to keep all of these copies of data under the same cluster topology. You can have different topologies for the cluster. Another common topology that I want to cover is the warm standby technique. So in this case, this is the east and west coast of US that you see on the picture. And the West Coast users have their database called DB1 that is replicated to the East Coast, and the East Coast users have a replicated database called DB2 that is replicated to the West Coast. And this is mainly done for protection. If anything, typically the users on the East Coast and West Coast end up on their designated regions and databases. But if failure was to happen, the West Coast or the East Coast database cluster can actually take over, and you can carry all of that workload over there. If there's a regional failure, you can essentially, using this technique, protect against that failure by having a hot standby. Now, this is obviously a great way to protect against regional failures. You can have this warm or hot standby server that can actually take over the workload. Again, the writes are going to a single version of the database. The other copy is only activated when it can be activated for reads, but it's only activated for writes. So there are no write conflicts in this scenario. And you can, again, independently size each cluster using this technique. And both of these topologies use the replica capability that's available today. I'm going to talk about a new topology that will enable with the coming Multimaster technology. So in this topology, you gain the collective benefits of being able to write actively in each one of these geographies, but also have fast replication. So let me take a step back and explain the picture. There are 3 sites here, and all 3 sites read and write the data locally, but they have a bidirectional replication between each one of the other clusters to be able to communicate all the writes to the other clusters. And the CRTC technique that we talked about is the underpinnings of how we resolve the write conflicts and smartly achieve a consensus among all of the conflicting writes that are happening to the data. So this Multimaster database technology is great for distributing your content close to users. Just like the other techniques, you will have your data locally. It protects against regional failures, just like the previous topology, but it allows you to have concurrent writes to all regions. And with the smart conflict resolution mechanism that we have through CRTC, you essentially gain all of the benefits all at once without having to be concerned about reading or writing across geographies. And again, with this technique, we continue to support independently sized regions for each one of the clusters. So site A or site B don't have to have the exact topology. You can add nodes, remove nodes based on the specific needs of each geography. Now, we've covered an overview of Redis enterprise technology. We've talked about the Redis enterprise architecture and our replication techniques, and I've covered a couple of the common topologies. I hope this was a useful coverage of our capabilities in a short amount of time. But I'll say thank you and take any additional questions that people have. All right, I see one more question come in. Let me read that out. If I have open source Redis, how do I take advantage of these functionalities? Well, it's pretty easy. The application compatibility is fully there, so you can simply take your application, change your connection string, and point it at us, the Redis Enterprise platform, and you can start taking advantage of capabilities like Replica or in not so distant future with Multimaster, with the active write capability that come with Multimaster databases. So it's a transparent and easy porting exercise that only involves essentially the connection string. I think with that, I'm going to close. I appreciate all of you staying here. Thank you very much. I hope the information was useful, and my contact information is there if you want to get a hold of me. Thank you.
Well, thank you, Shihan. And thank you for joining us today. For an overview of upcoming webinars, please visit redislabs.com and register. Bye for now.